Solving nonlinear inequalities. Here's an example. X squared, notice that's not a linear. Once you see a power, it's not a 1, it's not linear. That's a quadratic equation, absolutely. What I like to do with these, the way I do them, step number 1, I move everything to one side. So if I move everything to one side, I'm going to have what? X squared minus 2x. I like to put them in order. Very good. Minus 3 greater than 0. There's a couple of ways to do this problem. You can actually graph it and see where the graph is above the x-axis because it says greater than 0. But nobody wants to graph that. That's not the best way of doing it. So then what am I going to do? Factor it. X minus 3, x plus 1. Let's set it equal to 0 when you factor it. Find these numbers. I call them critical values. When is this going to be 0? When x equals minus 1, what else? Plus 3. Good. Minus 1 and 3. You set each one of them equal to 0 and solve it. So if this is my number line, this is the minus 1, and this is the 3. Now I'm not sure where the answer is. So step number 3, we take test points. What do I mean by test point? You pick a point in each one of these intervals. Plug it in to see if it works right there in the original problem. So to the left of minus 1, what are you going to use? Negative 2, okay. Between minus 1 and 3, what do you want to use?
0.
0 is a good number. More than 3? 5 is good. Any number, 4, 5, 10, whatever you want to use. Let's test them. Here's the minus 2. Is minus 2 squared minus 3, is that bigger than 2 times a minus 2? I'm going back to the original problem. Testing it right there. What's minus 2 squared?
4.
Is 4 minus 3 bigger than negative 4?
Yes.
Is 1 bigger than negative 4? Yes. That says this point is a solution. Yes. Now, let's be careful. Let's take another peek at it. No, I'm just stopping until you finish writing. Was there an equal sign here?
No.
That tells me these points, the critical values, will not be a solution. Will not. Because there's no equal sign. If I had an equal sign, these would be what? Closed circles. So this one solution, we know that's a yes, that's a solution. Let's try the 0. Is 0 squared minus 3 bigger than 2 times 0? That's a negative 3. Is negative 3 bigger than 0? No. This piece or this segment is not a solution. And where's the other one? 5?
No, that's going to happen.
Not always. 5 squared. When you have fractions, they don't work that way. He said because he says yes, no, he thinks it's going to be yes, no, yes, no, yes, no. Usually, 90% of the time, yes. But when you start putting fractions, no. 25 minus 3, is that bigger than 10?
Yes.
That's a yes. That's also a solution. So where's my answer? From where to where? Negative infinity to where? Negative 1, not included. Union 3 to infinity. That's an OR. 3 to infinity.
Or it's always going to be an or when you have two different ones, right?
Yes. An and will have to be like a middle piece to be an and. So that's how we do non-linear inequalities. We move them to one side, we factor them, we use test points. We'll take a couple of examples like these, go through them, and see what will happen.
So your nonlinear inequalities.
Yes, because the power was a 2.
Yeah. Are they only related to quadratic equations?
Nope, nope.
Can they be like triangle, which is three sets of different lines?
Triangles? What do you mean triangles?
Like, like.
How about this one?
Oh, that's a polynomial.
Oh, I remember these.
That's nonlinear.
Wait, are we doing this?
Yep.
Okay.
That is a nonlinear. Move it to one side, it's already done. Step number 1 is done. Step number 2, can you factor it? By the way, how do you factor when you have 4 terms? There's a name for it.
Completing the square?
Nope. 4 terms. I'll give you a little hint. It goes factor by,
Completing the square.
not completing,
No, trying.
By substitution? Quadratic?
grouping. Factor by grouping. Look at the first 2. Look at these 2.
And then factor those sets.
It's called factor by grouping. I'll put it down so this way I heard it before. Let's look at this. The first 2. Anything in common?
Yes, x squared.
And then you have an X.
And this is what? Nothing really.
One into that.
There's a 1. You want to put a 1 here? Okay. I'll do that. 1 times x minus 1. He wants to put a 1. I like that. Actually, I like that choice.
Because then you're going to use x minus 1 of that.
Very good. Now you notice x minus 1 common to both of them.
Yeah.
If you factor that out, what's left?
Square plus 1.
X squared plus 1. Now you're multiplying 2 things, your answer, you want it to be 0, right? Let's find out when is this going to be 0. Let's find the critical values. Because that will give me the numbers on the top. Remember the numbers I need on the top? I need to get them.
Why am I confused?
Well, I got it.
Yeah, I don't know what happened there.
Huh?
After,
Yeah, I don't understand what just happened.
after the second line down, how'd you get to the third one? What happened?
These are common to both of them. Just like if you have x squared y plus y. How would you factor that?
But we're not dividing. We're dividing.
No dividing, factoring.
Oh, Jesus.
X minus.
So that's another.
Oh, you just took it out again.
I took the y out because it's common to both of them. What's left?
X squared plus 1.
Yeah, so you just took
Yep,
X minus
that's what we have. X minus 1 is common to both of these terms.
So we took it out and then.
So
Where's the y? What y?
I'm just making a new problem. That's a new problem.
Oh.
Yep. I said if I have this problem,
Okay.
how would I factor it? There's only y common to them. I'll take the y out.
Okay. No,
What-
it's not that. It's more the x minus 1.
Well, let's stay with this one first.
Okay, yeah.
When you take the y out, what's left in the first one?
Square plus 1.
Yep, well, that's the same thing.
Yeah, no, I understand that, but when you go down to the next.
Yep, that's the same thing. This is common to both of them.
Yeah, so you put the outside the parentheses.
Put it outside the parentheses. What's left in the first group? The x squared plus what's left in this one?
Oh, that's it?
That's it.
Because they're the same.
Yep.
Is that 2 into 2?
Just like if you had, and I'm not being funny here, if you had x squared times cat plus cat, what do they have in common?
A cat.
The cat. Take the cat out. What's left? x squared plus 1. When you take the whole thing, there's a 1. That's what we have. The cat here is x minus 1. It's common to both of them. So if you take that out, what's left? X squared plus the 1. Now, two things multiplied, you want the answer to be 0. That means one of them has to be 0.
So now we're gonna set them equal to 0. Yeah.
We need to find out when is it going to be 0. Well, when is this going to be 0?
That's
1. And when is this going to be 0?
Can't.
Never. You're right. Because if you take the 1 to the right side, what are you going to have?
X squared equals negative 1.
How can a number squared be minus?
Nah.
Can't be.
Imaginary numbers.
Yep. So there's only one number that will make that equal to 0. So we only have one cut here. There's the 1. And notice there's no equal sign. That's open parentheses. Now we take a test point to the left, like a 0. A test point to the right, like the 2. And plug them in.
It's greater than 1.
Is 0 squared cube minus 0 squared plus 0 minus 1. Is that bigger than 0? Is negative 1 bigger than 0? No. This is not a solution.
So it's that one.
So it can only go.
It's
basically
2.
we're determining which way it's gonna
Yep.
go.
2 cubed minus 2 squared plus 2 minus 1. Is that bigger than 0? 8 minus 4 plus 2 minus 1. Is that bigger than 0?
Yes.
Is that 7? Yep. That's a yes.
What are the critical values again for?
1. Just the 1.
Just one.
Just 1.
It's actually 5.
5 is it? Okay. Whatever. One of those numbers.
Sounds like it's
So it's from 1 to infinity, the solution. So when you have 4 terms, it's factored by grouping. Grab the first 2, grab the last 2, and hopefully your goal is to make sure these are common, because if these are different, it doesn't do you any good. So you got to work with these to make sure. Sometimes you pull a minus sign in the front to make sure these are the same, because once they're the same, they become the cat here, and you can pull them outside. If you have a cat and a dog, you can't factor anything out.
Maybe hard.
What about if you have a fraction? That's nonlinear. Let's look at a fraction. Once the power is not 1, it's no longer linear. So this is cube, it's not linear. Fraction is not linear, because when you bring that power up, it becomes a negative power. And where do you see this? I might ask a question, find the domain. Remember the domain?
The range.
The domain and the range. The domain are the x values. What can you use for x values?
Is this still 17.3?
Yes. Find the domain. Well, the domain is what can we use for x values? Can you use any number?
No, because x plus 4 can't equal 0.
Oh, good.
Yeah.
So the bottom can't be 0. That's good. I like that. So x cannot be negative 4. Because that's a fraction. What happened when x is negative 4? You'll be dividing by 0. Can you divide by 0?
Nope.
Perfect. That's one of them. But that's not the only answer. Let me give you an example. Can I use a negative 10 for x? Can you use a 0 for x? If you use a 0, this becomes what? Negative 3, and this is 4. Can you take the square root of a negative number? No. So you need to make sure that what's under the square root is greater than or equal to 0. And at the same time, it can't be negative 4. Gotta make sure you remember that. Because negative 4 will make this fraction undefined. So not to forget about that negative 4, here we go. I'm going to make that an open circle. Just in case. I don't want to forget about it. Let's look at this problem. How do you solve this?
You set them to 0.
Well, take the top, set it equal to 0, the bottom, set it equal to 0, both. And see what the critical values are.
not equal. Oh, yeah.
Give me 3.
So x has to be 3 here, and x has to be what here? Negative 4. I already have the negative 4 circle saying can't be.
3 count.
Can x be 3, by the way? Yes, because it could be 0. It's all right to have a 0 on the top when you have a fraction. So 3 is okay, but 4 is not, or negative 4.
Square root of 0 is 1.
0.
Oh, it is 0.
Negative
Yeah.
3 would be okay on the bottom.
Negative 3. It could be. I didn't test it yet. But I'm just saying the 3 itself. I'm just looking at the value that's the critical value. Can x be 3? Yes. Can x be a negative 4? No, because that makes the fraction undefined. That's why I have a closed circle and an open circle. Now is a test point in each segment. Below the negative 4. How about negative 5? Between negative 4 and 3. More than 3. Any number you want to use. And let's test them. Is negative 5 minus 3 over negative 5 plus 4, is that bigger than or equal to 0? That's negative 8 over negative 1. Is that bigger than or equal to 0? Yes, that's an 8, right?
Yep.
You're right, that's a yes.
That's a solution.
That piece is a solution. Let's try the 0. Is 0 minus 3 over 0 plus 4, is that bigger than or equal to 0? Is negative 3 over 4 bigger than or equal to 0? No. That's not a solution. What about the 5? 5 minus 3 over what? 5 plus 4, is that greater than or equal to 0? What do we have here? 2/9. Yep, that's bigger than or equal to 0. That's a yes. That's a solution. So my solution then from where to where? Negative infinity to where? Negative 4. Or, add to it,
Wait, it's an or because of the sign?
it's this piece or that piece. Yep.
Because they're separate.
Yep. And the other one from where to where? 3 in our square bracket on 3 because it's included all the way to where? Infinity not included.
Is that an and or an or?
That's an or. When you have two pieces, always an or. It's this one or that one, or could be both.
Forgive me, but what happened to the square root sign?
Well, we don't care about it. We're just saying what's the domain, right?
Yeah.
You're saying what values of x can you use?
So it doesn't matter.
Nope.
Okay.
All that's good.
Figure out what you
Yeah,
can't do.
all the square root telling you that this fraction, this piece, has to be bigger than or equal to 0, and it can't be a negative 4. So I can let x be any one of these numbers, and I'll be okay. I can let x be any one of these numbers, and I'll be okay to take the square root of that. But I can't pick a number in between, because that will not work.
Yeah.
What I want to find out, Professor, just like he said, when you move from the square root to that, did you just multiply by the square to get that?
No, I didn't even do that.
Because it doesn't say solve, right?
Nope, it doesn't say solve it. Yeah, exactly. It just says what's the domain. There's no equation to solve. I don't have equal something. I don't have that. So you're not solving for anything. You're just saying what's the domain? What can you use for values? And when you have a square root, the value under the square root always has to be greater than or equal to 0.
The problem I'm having with the way that you did it is that with the square root, it doesn't show me whether it's a minus or a plus. And those things that,
What do you mean minus or plus?
well, the square root of a number, you know, the minus the square root number or the plus
No,
root.
square root will never be minus.
Well, let's just say the square root of 4.
Yep,
Then
it's
that
2.
is
Nope, just a 2. Square root is always a plus. The square root of any number. When you see that little hook there, that tells you only
Does that
plus
say
2.
plus or minus 2, Professor?
Huh?
Square root of 4 could it be plus
Nope,
or minus
nope.
2?
No, the square is always a plus. What you're thinking about, if I take plus 2 and square it, that gives me a 4. If I take a minus 2 and square it, that gives me a 4. But once you put the square root is always a positive value.
I think he's
Because the
thinking of,
definition-
like, a negative. I think he's thinking of like when we doing the whole Denny's, you know how when you're doing the, Pythagorean theorem, you have to determine if
could be
your
positive
answer
or
is
negative?
So he
Yeah.
sees
Yep.
plus or minus squared.
That's because you have x squared equals like 25. If x squared equals 25, then x equals, and what I wrote there, plus or minus. I put these outside the square root of the
I think
25.
that's why he's
Yeah,
getting
that's what
confused.
I'm.
Yep,
yeah.
that's different. Notice I put plus or minus because the square root has to be a positive number. It will never give you a negative number. So this is a 5, and that's why the plus and minus sitting out there.
Yeah.
But a lot of people see that, they think it's plus or minus because they go, well, 2 squared is 4, negative 2 squared is 4. That's if it's written like this, x squared equals to 4. What's x? I mean 4 here. What is x? X equals either plus 2 or minus 2. But once you see that square root symbol, that is has to be a plus. Only plus. There's no minus to it.